In this example, we're looking to find the radius of a planet, Tatooine, which is the fictional planet from Star Wars. We know something about the planet. It's got more mass than Earth, 3 times the mass, in fact, but objects on the planet experience the same gravity as they do on Earth. So using this information, we should be able to find what that radius of the planet is. Like any problem, let's set up the information we know. Should we start here? Well, we know the mass of Earth is given to us here. And so we can figure out what the mass of Tatooine is, which is just 3 times the mass of Earth. And in my calculator, I can just multiply it times the mass of Earth. Now, I've actually have the mass of Earth stored as m in my calculator. Again, we can use that by typing that value, hitting the STO button, and then putting that in as the value. So in my calculator, all I have to do is put 3m. And I find that the mass of Tatooine is 1.79 e to the 25. Another little trick, I plan to use that mass later, so I'm just going to store that as x, just to save it later so I don't have to retype it. But I'm going to write it down anyways. 1.791 times 10 to the 25 kilograms. So a large, massive planet, 3 times the mass. But they tell you that it experienced the same gravity as on Earth. And the gravitational field strength, we use Ag. And since it's the same as Earth, we'll use what it is on Earth, which is 9.81 meters per second squared. And what we're trying to find is the radius of the planet. And if we're on the surface, the radius of Tatooine would be also known as d. And so we're trying to find what d is. And we know Ag, we know the mass. Big G is a constant, so we can use our gravitational field strength equation, which says that the strength of the gravitational field is equal to big G times the mass of the object creating the field over the distance to the center of that object squared. And so when I plug in the values I know, really we have big G, we have the mass of Tatooine, and the distance to the center would be the radius of Tatooine, and that would be squared. And so when I plug in my values, I can actually solve for that radius. So I know that Ag is 9.81. Big G, I also have that stored in my calculator. Rather than writing this giant number right here for big G, I'm just going to save space by writing G right here. The mass of Tatooine was 1.791 times 10 to the 25. And the radius is unknown, a radius of Tatooine squared. And so now we have an algebra problem, right? We need to solve for that radius, and it is in the denominator. So we got to do a couple things here. The first thing we might do, there are some tricks that we'll learn when you do this type of math over and over again, but ultimately we need to get that radius out of the denominator. So I can multiply both sides by the radius of Tatooine squared, and that's going to eliminate it from the denominator. And it's going to get on the left side. But then I have that 9.81 over there. So in the same step, I'm going to divide the whole problem by 9.81. And now I have that the radius of Tatooine squared is equal to big G times that mass of Tatooine, which is 1.791 times 10 to the 25, all divided by 9.81, the acceleration due to gravity on Earth. And if I'm going to solve for r, I need to then take the square root, right? So we just did a bunch of math here. I'm going to take my calculator now, and I'm going to say the square root of big G, alpha G, and this is where I can use that x value. I'm going to multiply by the mass. Well, I just stored that as x, and I'm going to divide it by 9.81. That whole thing is under the radical. And when I do that, I get the radius of Tatooine, right? So I get this big number. It looks like it's going to have 1, 2, 3, 4, 5, 6, 7. 1.1 times 10 to the 7 is the radius of this planet. The radius of Tatooine is 1.104 times 10 to the 7, and that would be in meters. Earth is 10 to the 6, so it's about an order of magnitude bigger than Earth, which would make sense if it's more massive. It would also need a bigger radius to have the same gravity, right? So this is our answer for the radius of Tatooine, 1.1 times 10 to the 7, about 11 million meters. It's a bigger planet. It's more massive. Since you're further away from the center, that would allow that gravity to be the exact same as Earth, even though the planet is more massive. Hopefully this helps. I'll give you an example here where we're applying these equations. Again, the algebra is typically where guys run into the issue. Make sure you remember to take the square root to get that squared term out of there. And be careful when you have an unknown in the denominator like I have here with the radius of the planet. Best of luck.